Scalable platforms across machine vision technologies unlock lot size 1. My name is Victor Smedby. I'm a strategic product manager at SICK for machine vision. And I'm going to share this topic with you and how our platform SICK Nova meets modern manufacturing challenges. Today, I will first introduce a bit who we are at SICK and what we are doing with machine vision. I will talk about lot size 1 applications and what kind of challenges they face. Then I will talk about our platform SICK Nova and how SICK Nova tackles a lot of these issues. So first of all, SICK, sensor intelligence with global reach. We are a roughly 2.3 billion euro sales company and have over 12,000 employees. About 1,700 of those are in R&D, so we are a fairly R&D heavy company. And we have 60 subsidiaries worldwide and really do cover more or less the entire world. We were founded in 1946 and we have our headquarters in Waldkirch in Germany. We are active in factory automation, logistics automation, process automation, and I would say that we're most famous maybe for our safety products and some photo switches and things like this. But I want to talk about machine vision. Because machine vision at SICK also has quite a long and rich history. It starts in 1985 in an office in Sweden. And you can see the first few years are filled with a lot of world's first. We made the world's first CMOS vision sensor. We made the world's first 3D smart camera in 2005. And then the 3D cameras is maybe what we have been most famous for, but we quickly expanded into smart cameras, 2D smart cameras. And you can see we made high-speed 3D cameras with color support. We've done robot guidance systems. And in 2018, we again broke the speed record with the Ranger 3 for high-speed laser triangulation 3D. In 2019, we for the first time showed our Inspector smart camera or vision sensor with deep learning embedded, and I think it's a nice parallel here to our shared German-Swedish heritage, how the German Chancellor Angela Merkel at the time and Prime Minister Stefan Löfven were at our booth checking out our deep learning running at our vision sensor here in the image. After this, we launched our platform called SICK Nova that I will talk a bit about today, and it marks a bit of a new era in machine vision in SICK, because this means that we try to bring everything together, all the technologies we have, into one umbrella where everything behaves the same and works the same. We keep expanding into 3D with the Ruler product in Ruler 3000 product in 2020, and with in Nova 2.0 we expand our AI capabilities with edge learning as well. So what have we done in 2024? Well, a big launch for us was the Inspector 830, which is an AI-centric vision sensor. We've released the Ranger 3 high speed for additional performance and color support. We introduced the Surface Plus technology for our 3D cameras, which lets you find really the surface structure extracted from the products. And we launched SICK Nova 3D for Ruler and LMS support. But I'm a little bit getting ahead of myself. I will come back to that later. So now, let's get back to the history of modern manufacturing and lot size 1. Because how manufacturing started, of course, as we know, is in small scale, making individual objects. And then the big revolution coming from serial production, mass production, the famous quote by Henry Ford saying that you can get any color you want as long as you always choose black, illustrating how making large batches was key to unlocking the efficiency in mass production. But I think this statement is quite a nice summary of where we want to go in modern manufacturing with lot size 1. We want to make a manufacturing system that is capable of producing single products, but at the cost of mass production. So keep the efficiency of mass production, but still be able to do single product manufacturing. And what are then the key benefits of lot size 1? Well, I would say the first topic is efficiency. We learn through lean manufacturing, of course, the Toyota way and so on, that reduced batch size is key to reducing work in progress, reducing waiting times, and minimizing occupied inventory, which is increasing efficiency. Additionally, reduce risks of overproducing or generating waste by doing small batches, ideally batch size 1. Secondly, and what I personally maybe find more exciting, is the customization aspect. Because here we can increase the customer convenience, we can increase the product competitiveness, we can make improved branding, and maybe most cool of all, make completely new product segments. For example, what you have here, this orthodontics product can bring better teeth health to people who maybe in the past could not have access to it for various reasons. So completely new product segments through technologies like additive manufacturing. So in SICK, we have worked a lot with lot size 1 production, and I can really recommend this video here. If you have a phone, you can take the chance to scan it now. It's a YouTube video on how we work with lot size 1 production at SICK in our facility in Hochdorf. And it both shows you how it works and shows some discussion on how it can be implemented. So I can really recommend this. But now I will focus more on machine vision and applications related to lot size 1. So I like to kind of split in the application space like this. First, I say we have these custom bundles. So for example, when we do shipments that are combined, say that in this example we have fruits. There we are. Fruits in a container that needs to be shipped to the right shop and make sure that it has the right content in it. So this is just counting things, keeping bundles. It can also be optional accessories that need to be verified that they are available in the box when the customer has checked that box that they want that accessory. Another example is medication packaging. It can be a great safety aspect to have pre-packaged medication with exactly the right pills for the right day, so that you know that the person who's taking those pills cannot make mistakes. Next up, we have custom assembly. For example, in this example, when the customer has chosen to have a specific decor in the car, we can make sure that they get the right decor in the right product, minimizing the risk for that we ship the wrong product. Another example is electronics, where a customer can choose a specific design, maybe choose which color a specific component can have, combine them in different ways. This has been done, for example, in manufacturing of video game accessories and things like this. And aesthetic personalization. For example, promotional food items. I'm sure there are many of them here today, but also for celebratory situations, a wedding or maybe a birthday, to get a customized product packaging. We also have electronics. For example, if you order a cell phone and ask it to get custom engraved, to make sure that it's engraved the right way for the right customer. Lastly, I would say custom fit. And here I count, for example, sports equipment. What you see here is custom-made shoes. They can be, for example, companies doing 3D scanning of feet and then generating a specific shoe for that one customer. Can also be medical dental device, as we saw before, or for example fitted furniture such as kitchen or office furniture. So just summarizing a little bit what we have here in terms of challenges. What we see is that we have a lot of different algorithmic challenges. There are many different needs for different applications here. We also have different needs in terms of technology and performance. Is it 3D or 2D? The measurement range can vary greatly. So we see that we need a very extensive span of options here to solve all these applications. In addition, we have challenges in integration and flexibility, because of course integration is a key aspect of lot size 1 production. We need to be able to control the sensors that they check for the right aspects of the product. And with this, I would like to introduce SICK Nova. And at the surface, SICK Nova is just easy and accessible machine vision. We let you solve machine vision tasks in a web GUI, which means that without any kind of special software or training, you can just point and click in the user interface to solve vision applications. There is built-in documentation and help, and it runs directly on the device when you configured it, so there's no need to leave a PC there or anything like this. We have integrated toolboxes with rule-based tools to check measurements. We have OCR and DPM code reading, and you can easily use AI tools to check for appearances combined with these rule-based tools. And of course, you can combine and link tools together to make more complex inspections. We also have I/O control, communication over network to communicate results, and advanced tools for things like managing data and user management and everything you could imagine. So looking at the analysis aspect, like I said, rule-based tools allow you to measure distances, angles, and things like this. And with DPM code reading and text reading, you can easily track items in production. And this means that you can very easily tune these so that they measure exactly the right aspect. From a control system, you can make sure that the device itself is measuring the distance that is valid for this one piece that you're making. Next up, we have AI trained on device. And we have, basically this is AI where you collect, train, and execute everything directly on the device, so you never need to depend on a powerful PC. And we have AI classification, anomaly detection, and object detection here. And they take care of different aspects of the solution space, everything from verifying textures, sorting, to finding defects in surfaces, and counting objects. We also have AI trained with DStudio, which is our more advanced offering, which allows you to still collect and execute everything on the camera, but we have a powerful cloud service that allows you to do an optimized training, and with increased accuracy and speed, do AI classification and object detection. I write coming soon here for object detection, but if you come to our booth, you will see that it's already running very well. There's also a system here in our cloud service for doing data management and for collaborative annotation and things like this that really helps if you're solving larger projects. But connecting back to lot size 1 production, I would really like to highlight these 3 topics. Excellent integration, designed to be customizable, and scalability in hardware and software. And I really think that these are the key aspects of a scalable platform that is needed to support lot size 1 production. So how we chose to do this for integration was specifically that we spent a lot of time making dynamic configuration of how you transfer data. This means that the camera have exactly the right interfaces that it needs for order to set the parameters, for example, depending on which item you're just about to produce, or getting the right information out of the camera. We also have a customized export of user data types or function blocks for world-leading PLC brands, which means that the integration is extra simple, and you get exactly the parameters that you had in your vision analysis moved automatically into the PLC world. Of course, we also have flexible TCP/IP integration options, and you can very easily remote adjust parameters or use the very convenient job system, or image logging options. All this means that you can easily integrate for single batch adjustments of parameters, and you have a highly customized control of the camera. Next up, it's designed to be customizable. Nova, our platform, we decided to make it so that every module, what we call a Nova tool, is self-contained, and our customers can develop their own tools in the same way as we do. So we have the tools called App Studio and a Visual Studio Code extension, if prefer, where you can develop your own modules running in this system exactly in the same way as we develop our module, and they can work together with our modules. In addition to this Lua interface with the 6 sensor algorithm, we also support NVTech Halcon for most of our hardwares, and there you can simply use the Halcon functionality that you might already be using directly in this, and then easily integrate it into this world and using it on all different Nova products. So this means that you can customize and tune algorithms and run them on all different SICK Nova products. And what I think is a really powerful thing here is hiding complexity with customized tool for your use case. If we, for example, take this custom created shoe example, you could easily make a custom Nova tool that has exactly the parameters that are relevant for your shoe production, and you can hide everything else that is just interesting for the vision aspect. And that means that you can much more easily integrate the verification of these custom shoe parameters into the rest of the system, and it's easy for people in your factory to handle. Lastly, it helps you package your knowledge and your intellectual property for licensing and distribution to your customers. So you can choose to use our licensing system to license it out, or use our distribution platform app pool to distribute this to your customers. Lastly, scalability. Scalability in hardware, first of all. Signova began as the platform we use for machine vision on the inspector cameras, from the tiny, tiny sensors that are this big to the big ones that can check entire cars. And after that, we expanded into streaming cameras with computation box, what we call pico and midi cams. But what we did then was to expand into 3D. And this was always the goal, to bring everything into one big platform. We started Visionary T Mini, which is a time-of-flight camera with really great ambient light resistance. And we also used the Visionary S, which is a stereo camera and also gives you 3D and color information. After this very year, we released support for the Ruler 3000, which gives you these excellent detail images you see in the background for really great laser triangulation image quality and great service inspections. And lastly, the LMS 4000, which is just really large-scale line scan time-of-flight 3D images. Additionally, in scalability, we have scalability in software. Because wherever you start here, you have the flexibility to change. So if you start out, you can choose a smaller toolbox of tools if you don't think you need all the tools. But then you can expand. You can, for example, try the AI tools even without the AI license. And if you see that you actually need these for your use cases, then you can choose to get this license and continue using it. We also have the flexible cloud service associated. So the unified vision platform provides flexibility to change camera technology and performance or form factor. It provides the flexibility to change toolset based on your own needs. It provides consistency across all devices for different algorithms, including AI. And as we've seen, that is necessary for the lot size 1 production. And compatibility with line integration or customizations that are then compatible across all these different devices and all these different technologies. With this, if you want to know more about this platform, I would again direct you to this QR code and scan it. It's an excellent tutorial series that I would recommend watching.
At least answer me this. Where do you think, pretty much the same question that I asked the previous speaker, where do you think is a possibility to get even better?
I think the direction we're going here is integrating more and more vision technology into this one platform. And I really love to see more and more come together, as we've seen only in the last few months. And I think we will see the same thing, even more technologies, even more form factor consolidated into the same platform, so that you know that you always have a path forward within this platform without having to relearn, without having to redesign integration, without to redesign customization.
Sure, yes. And have you already partnered with camera manufacturers whose products you can already integrate into the platform?
Today we have focused on our own cameras. There's no technical limitation per se for anything else, but we want to make sure that what we are offering is really working 100%. We want to make sure it's reliable, and we want to make sure that it fits into one highly functioning ecosystem.
Okay.
So that's how it is today.
Thank you.